Okay, everybody, we're going to continue on chapter 6, 6.3, which we have been on, and we're multiplying polynomials. The last video we did letter A and we did letter B. We're going to letter C, and letter C is multiplying polynomials. Now, what we mean by multiplying polynomials for section C, when we're multiplying two polynomials together, these are the types of problems that we're going to be looking at in this section. We're going to be multiplying a bi times a tri, or a trinomial times another trinomial. So when it says for section C, multiplying two polynomials, that means that neither one of the factors is going to be a monomial. One is going to be a binomial along with a trinomial, or two trinomials. Now, what we do when we multiply two polynomials of this fashion, we do like we did in letter B. We're going to distribute, and we're going to use the product rule of exponents when it is necessary. One of these polynomials must function as the distributor. And the one that we're going to allow to be the distributor is the polynomial that has the fewer number of terms. This is a bi, this is a tri. We're going to let the bi function as the distributor. This overall distributor is made up of two separate little distributors. Each one is going to have to be distributed over this trinomial. So we're going to set this problem up first. This is going to be our distributor. We begin by bringing down the first term of this binomial distributor. We bring it down, and we show that it's going to be distributed over this trinomial factor. Negative 2a squared, negative 5a, positive 4. And then immediately after this parenthesis right here, we're going to bring in the second term of this distributor. The first term was 3a. We set it up. The second term is positive 7. You bring down that positive 7, and that as well is going to get distributed over the negative 2a squared, negative 5a plus 4. And now we distribute. Positive times negative. Coefficients first. Negative 6. And now the product rule. A to the 1 times a to the 2. Add the exponents, a to the third. Positive times negative. A negative 15. A to the 1 times another a to the 1. Add those exponents, a squared. Positive times positive, a positive 12a. And then we move right over here and clear these parentheses. Positive times negative, a negative 14a squared. Positive times negative, a negative 35a. Positive times positive, a positive 28. And the final thing that we do is combine like terms. Simplify this polynomial answer that we've got. Keep in mind, now that we're combining like terms, you don't do anything more with the exponents. We only operate with exponents when we're multiplying. We are done multiplying. Now we'll combine like terms. There aren't any other a cubes but this first term, so we bring it down. Now let's go to the a squareds. We've got one of them right here, and we've got a second one right there. Combine them. Add the coefficients only. Negative 15 gets added to a negative 14. Negative 29a squared. Then we go to the a's. We've got a positive 12a. We have a negative 35a. add the coefficients only. He's a positive, he's a negative. We'll have to really subtract, and we should get a negative 23a. And then bring down your constant term. There are no other constant terms. Bring down the 28. Done. And there's our product. Each term of this binomial factor is going to function as a distributor over that given trinomial. Now we're going to go to number 2. And people, as we go to number 2, it too is a binomial multiplied by a trinomial. But I thought I would share this problem in another way. Some students like it. Some students really don't need it or don't care to do it in this way. But some people will like this. There's another means of multiplying polynomials together when it's a bi with a tri or 2 tris. You can set up a chart like we did with the word problems. Notice that this chart has 3 columns going down, and it has 2 rows going across. Here's an alternative. Some people like it. Take the 3 terms that make up your trinomial factor and head up each one of the columns of this chart by each one of these terms of that trinomial factor. 7x squared, negative 2xy, and y squared. There's the trinomial factor. The title of the rows, the binomial factor. One of the rows, a positive 4x. The other row, a positive 3y. And then we fill in all 6 boxes, and then we'll combine like terms. How do we fill them in? By multiplying the title of the column that the box is in multiplied by the title of the row that the box is in. So let's start with this upper left box. The title of its column is 7x squared. The title of its row is 4x. Let's multiply the 7x squared by the 4x. 28 x to the 1 times x to the 2, x cubed. Let's go to the top middle box. Take its column title, the negative 2xy, by its row title, positive 4 times negative 2, a negative 8. Be careful, x to the 1 times another x to the 1, x squared. Don't forget to bring down that y. And then the far upper right box, column multiplied by row, positive times positive, 4xy squared. No need of adding any exponents there. Bottom row, take the column 7x squared times the row that it's in, 21 x squared y. Box, lower middle box, column title times its row, negative 6 x, y to the 1 times another y to the 1, y squared. And then finally the last box, column by its row, positive 3, y to the 1, y to the 2, y cubed. And now we will write it. Upper left box contains the term x cubed. There are no other x cubes here. Bring them down. And I'll cross them out so we don't look at them. Go to this next box right here. You'll notice that its last name is x squared y. If you look diagonally from it, you'll see another x squared y. These two terms have the same last name. They're like, Combine them. A positive 21 with a negative 18, a positive 13x squared y. Then if we go, that takes care of those. We go to the xy squared term. There's another one right here as well in a diagonal fashion. Combine the like terms, negative 6 with a positive 4, negative 2xy squared, and then finally the little caboose, positive 3y cubed, and that'll take care of that answer. No, it is not for everybody. Not everybody wants it. Not everybody needs it. But it is a nice thing that can be done. Am I okay? Mm-hmm. All right, let's go to number 3. Final one. We're going to multiply two trinomials. It is going to be no different. T squared plus 4t plus 1. That's going to be multiplied by 2t squared minus t minus 5. One of the trinomials must function as a distributor. And since both of them have the same number of terms, we're going to let the first trinomial function as the overall distributor that we're going to use. The t squared will be the first distributor term over him. The positive 4t will be the second distributor term over him. The positive 1 will be the third distributor term over them. We'll set it all up first. It'll be a little lengthy. I'll compress it a bit. Bring down that t squared. Make a trinomial house. Inside that trinomial house, the second trinomial factor, 2t squared minus t minus 5. Go to the second term of this distributor. Copy down the positive 4t. That positive 4t now is going to have to be distributed to the second trinomial factor, 2t squared minus t minus 5. And then bring in the last distributor term, positive 1 times that same second trinomial factor. And now we'll distribute. Positive times positive. 1 times 2, 2. T to the second times t to the second, add those exponents. Positive times negative, negative. Bring down the t, add the exponents. 2 plus 1 minus t cubed. Negative times the positive, a negative 5t squared. Onward to the middle. Positive times positive, a positive 8. T to the 1 times t to the 2, add them up, t cubed. Positive times negative, a negative 4. Bring down the t, add the exponents, t squared. Positive times negative, a negative 20t. And then positive 1 times each one of these. Well, anything times 1 is going to keep everything the same. So positive 2t squared, negative 1t, negative 5. And now let's combine like terms. The first term of this overall elongated product has a degree of 4. It's a 4th degree term. There are no other 4th degree terms. Bring down 2t to the 4th. He's done. Let's go to the t cubes. We have one of them here. And we have another one right here. That's it. That coefficient is a negative 1. He's a positive 8. Really subtract. Positive 7t cubed. They're done. Let's go to the second degree terms. We've got one of them. We've got a second. And we have a third. Negative 5 added with a negative 4 is a negative 9. Negative 9 added with a positive 2, back to a negative 7, t squared. That's done. And now let's go to the first degree terms. The last name of t, Negative 20, negative 1. Negative 21t, and the caboose, negative 5. Done. There's our product. People, that's letter C. That's multiplying two polynomials together using the distributive property. We'll sign off. Hope it goes through. We'll reunite, and we'll take care of letters D and E in the next segment. Have a good day. Thanks.